we have a right triangle that has a vertex on this graph of 9 minus x squared, where x is positive. It has another vertex at the origin, and it has a third vertex on the positive x-axis, so at some point x0. And they want us to express the area of the triangle as a function of x. That's the main idea. So right now, let's go ahead and start drawing a sketch. I'm going to put a mark up here. Okay, and what is this value? Anybody know what value I'm going to make that? This is going to be 9, all right? And the reason why is because we come over here, we have 9 minus x squared. Now that 9, is that on the inside or the outside of our parent function? It's on the outside, so this means we have a shift positive 9. Because it's on the outside, we know that is a vertical shift up. All right, what does the negative do to the graph? It reflects it. So we have a reflection over the x-axis, so that means this parabola is going to be going down. So what I'm going to do is I'm just going to draw a sketch. Now we do have a whole quadratic function, but I'm only concerned with this part. Does anybody know why? Because x has to be positive. Okay, so we don't even need any of this part. We just need all the positive values of x. All right, and then I'm going to draw a point on here. So one of my points is x comma, and instead of y, what could we put here?
9 minus x squared.
Yeah, the y value we know is 9 minus x squared. Okay, so we have some point on here. That's one part of our triangle. We know the other one was at the origin. Okay. And then for right now, I'm purposely going to put my third point right underneath here, because it says we have a right triangle. Okay.
Will it always like say something like that?
Yeah, you would have to have a for this particular one, you would have to have that information, because we're going to be using the area of a triangle. And do you guys know what the area of a triangle is? 1/2 the base times the height. If we didn't have a right triangle, it makes it a lot more difficult to find that area, so we're going to kind of keep it simple to start with. Okay, so we have our right triangle here. Okay, can anybody tell me what this distance is? X. Excellent. All right, remember we said that this third point is on the positive x-axis, and that point is x comma 0. We actually don't know the value of x, right? So we just give it a variable. So that x could slide around as this x also slides around, all right, as long as it's forming a right triangle. Make sense? All right, so so our base of any triangle, we know this is, we're going to call this the base. What is the base here? X. And the height is generally, yeah, it's 9 minus x squared. I'm going to call this, I'm going to say y for first, y, but we know y is 9 minus x squared. Okay? So if the area is base times height, that means the area is really, oops, sorry, not just base, 1/2 base times height. If the base is x and the height is y, I'm just needing to substitute this in for y. Okay? So a lot of you guys will probably skip this step where you put the y, and you'll jump right to putting the 9 minus x squared in, and that's fine. So we get area equals 1/2 times.
Will it do this with like rectangles and like is it always a triangle? Is it always
Yeah, I think the next problem is a rectangle, so we'll take a look at that. And then y is 9 minus x squared. Okay. Now this 1/2, I do have parentheses here, but that's the same thing as just 1/2 x. So if we distribute, 1/2 x times 9 is 9/2 x, and then 1/2 x times negative x squared is just negative 1/2 x cubed. And this problem's just a little bit easier than the last one, because this is all they wanted you to find. Any questions?
This is still the